The problem name is Sachin rotated sorted array. So we have solved this problem previously by using the binary search. Here what we'll do, we'll search in left side. If the target is lying in the left half, if the target is lying in the left half, I will make I is equal to mid minus 1. Means this problem is solved before. You can see that video. I'll be keeping that in the description. And now in this video, what we will do is we'll find the smallest element that was rotated. I'll show you the example. Here you can see, here we can see that this is the smallest element. So we need to, this is the smallest element in the in this sorted array. Previously, how this array will look, it will look like this, right? 4 5 6 7. So if this is the array, we can directly do the binary search. What if here the array is rotated, right? So we need to find the smallest element so that we can search in the right half, and we can do the binary search in the left half. So we need to find the smallest element, smallest number. Let us say smallest number in the complete array, so that we can split the array into two halves. So in this way we can split the array into two halves, right? And we will do binary search here, this in this left half, and binary search here on the right half. We'll search the target in the left half and the right half, and if the target exists in any of the partitions, we will be returning that index. So for finding the smallest element in the array, how can we do that? We will also use the binary search approach for finding the smallest element. How we can find the binary search? How we can find the smallest element using binary search? So let me show you by explaining this example. So in binary search, what we'll do, we'll find the mid value, right? So 0 plus 6 divided by 2. I'm doing binary search approach for finding the smallest element in this rotated sorted array. So the mid value will be 3, right? Here 3. So we need to for moving either to right side or left side for finding the smallest value, what we'll check, we'll first check whether the mid value is if the mid value is less than a of high. If the mid value is less than or is equal to a of high, means it will definitely towards the left side. So I need to move to the left. If the mid value is greater than if the middle value is greater than or is equal to a of high, it is greater than, if that is greater than, mid value is greater than a of high. Here we can see 7 is greater than 2. Here high will be 6, right? 7 is greater than 2. So we can say that smallest element will be on the right side. Why? Because mid value is greater than the high, right? So we can say that towards the right we can find the we can find the smallest element. So I will move low is equal to mid plus 1. Mid plus 1. Is this so okay, let us see with the working with this example. Here we got mid value as 3, right? So we check whether 7 is less than or is equal to 2. No, it is greater than 2. So we need to move our low is equal to mid plus 1. So 7 is greater than 2. We move our low is equal to mid plus 1, which is 4. Low is equal to 4. 3 plus 1, which is making 4. So now the low will be here, and we again calculate, and we again go to the next iteration and find the mid value. 4 plus 6 divided by 2, and the middle value will come as 5. Here it is the middle value, and we again check whether 1 is greater than 1 is less than or is equal to 2. So this condition, as it is less than or is equal to 2, then we need to move high, we need to make high is equal to mid minus 1. High is equal to mid minus 1. So high will be pointing here and low also pointing here, and we again do the next, and we again go to the next iteration because still low is less than or is equal to high. So now what the low is pointing? Low is pointing at 4. High is also pointing at 4, and low is less than or is equal to high. Now I will again calculate the mid value. What is the mid value? 4 plus 4 divided by 2, which is 4. Now uh, now we again check with the same value. Is 4 less than or is equal to 4? Yes. Then what we'll do? We simply make high is equal to mid minus 1. High is equal to mid minus 1. And the high will be moved towards the left. Now low is pointing at 4. High will be pointing at 3, right? So this has crossed the indexes that this has crossed uh, the low and high are crossed. Now we can say that the low that we are the low at index 4 means the smallest element is at index 4. Then we'll be returning, we'll be return no, we should not return. uh, we'll split the array into two equal halves by using low. By using low, we can split the array into two halves. So here low is equal to 4, right? And the previous array will be 4 5 6 7 0 1 2. 4 5 6 7 0 1 2. So the now the low is pointing at 4. So the now low is pointing at 4. We will do the binary search from the starting 0 to till low minus 1. That is, uh, we'll do binary search from 0 to till how much we need to search, till low minus 1, and we'll be passing the target to search. If this is not minus 1, if the result is not minus 1, then we have searched the target and we will be returning the index that we found in this part. If this is minus 1, we'll do binary search. We'll do binary search on the low to high, like a low to till the end of the array. So low to till end of the array, that is n minus 1, and we search the target. If we found the target on the right side, we'll be returning that index that we found in the binary search. If that is also returning minus 1, we simply return at the end return minus 1. So let us write the code now. First what will be do, we'll take the size of the array. So into low is equal to 0, high will be n minus 1, while low is less than or is equal to high. Then what we'll do, we'll calculate the mid value. Low plus high minus low divided by 2. So we got the mid value. We check whether uh, nums of middle value is greater than or is equal to nums of high. This is the case. We simply move to the left side. As we discussed here, we can see here when the a of mid, okay, a of mid is less than or is equal to, okay, wait, a of mid is, the a of mid is less than or is equal to, that means we can find the smallest element towards the left. I is equal to mid minus 1. Else is the case where nums of mid is greater than nums of high. That means we can find the smallest element towards the right side. Here if a of mid is greater than a of high, that means smallest element is towards the right side. So we'll make low is equal to mid plus 1. Low is equal to mid plus 1. In this way, we have founded the low. The low is pointing at the smallest element, right? So we need to do the binary search here. I will write the binary search function. Binary search. What it will take? It will take the vector or the array, and it will take the low, and it will take the high, and it is also going to take the target we are searching. The target we are searching. So if low is greater than high, this is means the it is crossed, so we need to return minus 1. So while low is less than or is equal to, while low is less than or is equal to high, we will do the binary search, right? This is normal binary search, like searching the element. Low plus high minus low divided by 2. If here we are missing something, yeah, when no, we are not missing anything, we are in the correct format. Terms of mid value is equal to target. That means we need to return the middle index that we found. Else if nums of mid is greater than the target, that means we are too right to the target, so we need to make high is equal to mid minus 1. Else we'll make low is equal to mid mid plus 1. So if we don't find the target, we will be returning -1. When the nums of mid is greater than the target, that means we need to move to the left side. Okay. Otherwise, we will be moving to the right side. Okay. Now the binary search function is completed. So we will do the binary search here. Int left 1 or else left search index is equal to binary search of nums, and we need to pass from 0 to low -1. 0 to low -1, we will be searching. What we need to search? We need to search the target. Int right search index is equal to binary search of nums comma, from what index we need to search? We need to search from low to till the end of the array. So low to till the end of the array. And what we need to search? We need to search the target. So here, if left search index is not is equal to -1, that means we have found the target in the left side. Return left search index. Similarly, we will do for the right side also. Instead of checking like this, we can directly return right search index. Why? Because this will be returning -1 if the target is also not found in the right side. So we can directly return right search index instead of checking like this. Okay, let us verify our code. What we do? We take the size of the array and we will be doing binary search logic, where I will calculate mid, low plus high minus low divided by 2, and we check if the mid value is less than or is equal to nums of high. So there may be a chance of finding there will be a chance of finding the low value in the left side, and the opposite cases we can find the low value on the right side, and we will do binary search on the left half, and binary search on the right half of the right part of the array. And if we found in the left part, we'll be directly returning the search index that we found. If we found or not found in the right part, we'll directly return right search index. Okay. Okay, let us see one more corner cases for the sake of our code is working or not. Let me see with only single element. The low is pointing at here and the high is pointing at here, and what we are searching for the smallest element, right? So now the middle value will be the same 0, and low, and here same element, right? So this condition will be satisfied, and high will be crossed here. High will be crossed and low will be pointing at here, and we will be searching 0 to low -1 on the left left part, which is -1. This is returning -1 in the left side. In the left side there is no way to search, right? So in the right side, what we'll do, from the low till the end is also 0, right? And this is also 0. We will be searching in the we can also achieve our correct algorithm in the, if the single element is also there, we will be returning the correct value. Okay, now let us see with one more test case. 1 2 3 4 5, and mid value will be here, and a of mid is less than or is equal to a of high. Yes, it is correct, and we will move our high to here, and low will be pointing here, and we'll move again. We'll calculate mid again. 0 plus 1 divided by 2, which is 0. 0 is less than or is equal to high. 1 is less than or is equal to 2, so we again move to high here. So in this way, I will be crossing, and we will again search in this part. So now let us run this code. Okay, here end is not right, it will be n minus 1. Till n minus 1 we need to search. So this is working with the example test case. Now let us run with the all test cases that we have here. So this is also running. Now let me give here with a single number also we can able to search. If the target is 1, we need to return 1. So here we are returning the 0. Okay, single element is also passing. Now we will submit the code. Here one test case is failed. Now let us see that test case. 513 513 513 0 1 2. Okay, the middle value here is 1. 0 plus 2 divided by 2 is 1. 1 is less than or is equal to 3. Yes, it is correct. We will move, low is here, right? We will move high to the left side, but here the left part is greater, right? So here I have changed the code. Here we need to search till low is less than high, and high will be staying on the mid. I'll explain with you with this example, the failed test case. So 513, right? Now the mid value is at 1. We'll check is in the previous example what we'll do, we will be checking is 1 less than or is equal to high. The mid value is less than or is equal to high. As this is the case in previous, what we have done, high is equal to mid minus 1. But if we do high is equal to mid minus 1, the low is pointing here and the high is also pointing here. High will be pointing here at the 0th index, but the smallest element is it in the in this part, but we are moving towards the left side. So instead of moving the high is equal to mid minus 1, if you make high as mid, if you make high as mid, there is a possibility that we can achieve the smallest, we can return the smallest element, we can return the smallest element. So high will be at least pointing on the smallest element. So that's why we should not move, we should not make high is equal to mid minus 1. I have made it as high is equal to mid. So and if you continue like this, now low will be pointing at 0, high is pointing at 1. Now again calculate the mid value. Mid value will be 0. 0 plus 1 divided by 2 is 0, right? And we again check whether 1 is less than or is equal to 1. And we again end up in the and again high will become 1. But again this doesn't change the high, right? So we end up in a infinite loop. Like again the high will be 1, again the low is equal to 0, high is equal to 1, and again we'll be getting mid as 0, and again we'll be checking this 1 is less than or is equal to 1 at the, so mid value is less than or is equal to and high is equal to 1. So this is creating infinite loop. So what I have done is I continue the loop till low is less than high. So this can be this can make this can make the array. So low will be here. Here high is at 1, right? So we need to search. So we need to change the logic. Here high is pointing at 1, right? Here high is pointing at 1. That is the lowest element. So we need to make it as high. We also need to search from high to n minus 1. High to n minus 1. Now let me run this with the failed test case. I think my internet is not working. I connected with my internet again, and now we have changed the we are searching from 0 to high minus 1, and in the right side part from high to n minus 1. So we'll so this is the test case that we have gone wrong, right? So I'll copy this test case and I'll paste it in this and check whether the failed test case is passing correctly. This will work because we have changed the code, right? So now let us submit. Now the solution is working, and this is the code for this, and this is the normal binary search, and this is for finding the minimum element, and splitting the array into two halves and finding the and doing binary search on left half and the right half.